Introduction to three-dimensional geometry. We start with coordinate axes and coordinate planes in the three-dimensional geometry, and we move on to coordinates of a point in space. Recall that if we have to locate a point on a plane, we draw two perpendicular lines, name them as x-axis and y-axis. Then the coordinates of this point will be x and y. We say that these are the coordinates of this point with respect to the axis. But in actual life, we do not have to deal with points lying in a plane only. For example, consider the position of a ball thrown in space at different point of time. Say we have to find the position of this ball at particular time. Then how we will do that? Clearly, the two coordinate axes will not help us. We will consider as if there is a room around the ball, and now we will find perpendicular distance of this ball from the back wall and the side wall to find the position of this ball at this point of time. But we notice that only these two perpendicular distances will not be enough to locate the position of the ball, and hence we have to find perpendicular distance of the ball from the floor also. Also notice that the back wall, the side wall and the floor are perpendicular to each other. That means we are finding the position of this ball by finding the perpendicular distance of it from the three perpendicular planes, that is the back wall, the side wall and the floor. Say we denote the distances by x, y and z. Then the coordinates of this point will be x, y and z, and we will say that coordinates of this point are with respect to the three coordinate planes. So we can say that a point in space has three coordinates, and now we are in a position to understand the three coordinate axes and the three coordinate planes associated in the three-dimensional geometry. To understand the coordinate planes, let us remove the two walls, that is the front wall and the side wall, from this room so that we can see the three planes which are mutually perpendicular to each other. One plane is this one, the other is this one, and the third one is basically the floor, and we can see that all the three are perpendicular to each other. Now the point of intersection of the three planes, that is this particular point, will be named the origin. So let us name it the origin. These three planes are intersecting along three lines, first, second and the third line. Say this is x-axis, this particular line is y-axis, and this one is z-axis. Now we can say that the three planes intersect along the lines xo, x dash, zo, z dash and YO Y dash. Clearly, XO X dash, ZO Z dash and YO Y dash are perpendicular to each other, and these lines constitute the rectangular coordinate axis. Now, how we will name the planes we started with? We had 3 planes, so how we will name it? We will have the planes X, O, Y. So the first plane is X, O, Y. Then the next one will be Y, O, Z. So Y, O, Z, and we'll have X, O, Z. So these are called XY plane, YZ plane, and ZX plane. If we consider XY plane as the plane of paper or the horizontal plane, then the line ZOZ dash is perpendicular to the horizontal plane. In other words, the line ZOZ dash is the vertical to the plane. The distance measured upwards from the XY plane in the direction of OZ is taken as positive, and that taken in the downward direction from the XY plane, that is OZ dash, is taken as negative. Similarly, consider the ZX plane, that is XOZ, and the line perpendicular to it, that is YO Y dash, will be the vertical corresponding to the ZX plane. Then the distance measured to the right, that is towards OY, is taken as positive, and towards OY dash is negative. Similarly, by considering the YZ plane, we will have XX dash to be the perpendicular line, and hence OX will be the positive direction and OX dash will be the negative direction. O is called the origin, and the 3 coordinate planes divide the space into 8 parts known as the octants. Clearly in this figure we can see the 3 planes, XY plane, then we have ZX plane, that is the orange one, and the XZ plane, that is the red one, and they are dividing the whole space into 8 spaces, 4 on the top and 4 below the planes. Hence we have 8 spaces called octants. Now let us name the octants. Let us look at this figure. The octants could be named as X, O, Y, Z. So the first one can be X, O, Y, Z. Then the octant just behind it will be X dash O Y Z. Just adjacent to the first one will be x, o, y dash, z, and so on. We can have x dash o, y dash z. Continue, we will get 8 spaces. Also recall that we name the quadrants as first quadrant, second quadrant, third quadrant, and the fourth quadrant. We had x and y both positive in the first quadrant, x negative and y positive in the second quadrant, x negative and y negative in the third quadrant, and x positive and y negative in the fourth quadrant. Similarly, we can name our octants. Look at the following picture. If O is the origin, OX is the positive direction of the x-axis, OY is the positive direction of y-axis, and OZ is the positive direction of z-axis, then this is our first quadrant. Our second quadrant is just next to it. It will have x negative and y and z are positive. In the third quadrant, x and y are negative but z is positive. And in the fourth quadrant, we will have x positive, y negative, and z positive. Just below our first quadrant is our fifth quadrant, which will have x and y positive but z negative. Just below the second quadrant will be our sixth one. It will have, since it has x dash, so negative x, positive y, and negative z. Below the third one will be our seventh one, and that will have x negative, y negative, and z negative. Lastly, below the fourth one we have the eighth one, and it will have x positive, y negative, and z negative.